Hi, everybody. Okay, Jeremy has the main agenda item today. Give him a second to join. Hey, Jeremy.
Hey, how's it going?
Going okay? We'll give it one more minute, and then Jeremy, you have the entirety of the agenda today.
Cool. Sounds good.
Okay. All right, I think it's safe to go ahead and get started.
Awesome. Give me just a sec here. So I've been working on some prototyping, and I figured it'd be cool to start with a demo of what it would actually look like if we implemented the KEP with a very hacky implementation of the KEP. But I'm having some technical difficulties. I need to join from another computer.
Okay. While you do that, since we last talked about the multi-cluster services KEP, I realized that there needed to be like some maintenance done on the list of like SIG multi-cluster leads, and thought about, you know, what next steps would be on the KEP. I think where I'm at this point is that we can probably commit it in a provisional state and just keep it there while we prototype.
Yeah, that makes sense, I think. Make it easier probably for people to comment. Yeah, I think also we have to actually create our SIG multicluster directory just as bookkeeping, because there's no owners or anything right now.
Yep. Yeah, I am gradually working on that today.
Okay, awesome. Okay, so I'm trying to share my screen. It says host disabled attendee screen sharing.
Okay, let's see. Okay. All right, you should be able to do it now.
Perfect. Okay, so here's my very blurry command line. So I just figured I'd walk through a demo.
You might want to bump the font up 1 or 2 ticks.
Yeah. Is that better at all?
Yeah.
Okay, cool. So so I'm just going to run through the scripted demo, but it's all live against a kind cluster, actually 2 kind clusters. So first I'm provisioning networking across both clusters, thanks to a tip from Antonio Ojea. And now just kind of deploying, this is very similar to a kind of demo, the concept I did earlier. I'm just deployed a service in each cluster. The service basically just has a simple server that responds with the IP address of the pod and a tag. So this one has cluster A, there's another one in cluster B. But the new addition is the service export, which is just that name mapped resource we talked about a couple weeks ago. And other than that, this is just a normal deployment. So we'll start by we'll keep going, and there's also a pinger in each cluster that just basically logs requests it makes to the service and the response. So in this case, cluster A is talking to cluster A, cluster B is talking to cluster B, and we can see that we've got regular endpoints, no change, but now I'm exporting the endpoints from each cluster and modifying them just a little bit. And so these exported endpoints, I've added just this multi-cluster Kubernetes.io/service name label, which looks a lot like how endpoints work today, or endpoint slices work today, with a Kubernetes.io service name. This is just the multi-cluster .kubernetes equivalent. And now we'll actually import these slices into each cluster. So each cluster will now have the original exported endpoint slice as well as 2 imported endpoint slices. So now we can see here, there's the original and then the 2 imported. The original is for the service, the imported are for the imported service. But now we're going to actually create the import. So this is my shell script as the implementation, the controller, actually creating the full, all of the resources necessary for import. And so just applying that service import, it just has the IP, and that's really it, and it has the same name. Now we're looking at the original pods. Again, no change because we've decided not to impact the cluster.local space at all. But I'm going to replace the service URL with the supercluster IP in my deployments. And what we should see is that it now starts talking to the supercluster. So they've been reconfigured. And now when I look at the output, I can see here it's a mix of cluster A and B and a mix of cluster A and B for both clusters. So that's kind of the simplicity of the experience for consuming this that I want to shoot for. This is implemented with kubeproxy, actually updated to understand these resources, which was a good experience to understand what it will actually take to properly do this with kubeproxy, which is definitely doable, but significantly more work. So any questions about that? And then there's some topics I figured we could discuss today on the cast.
So in this demo, are you playing the role of the controller because you're creating the service import?
That's right. I am the controller, or I guess more accurately, my shell script's the controller. But it just goes to show that you could actually create a very kind of dumb controller with Bash.
And so we're seeing the pinger logs that are just getting information about what pings they're getting from the different endpoints?
Or which endpoint they're talking to. So each of my hello service pods just responds with its pod name, the tag I assign it, which is the cluster name, and its IP address. So that pinger pod is always talking to first the cluster.local service and getting a random endpoint, and then the supercluster IP and getting a random endpoint, this time across all the clusters.
Okay. I guess I missed where the supercluster IP came from.
Oh, right here. I replaced the supercluster IP in the pinger deployment.
Okay. Okay.
And then I defined it manually because this is something that the implementation will provide, but me as the implementation provided the IP address 1042.42.42 on the service import.
So what would you see as like a next step that would be, or is there an obvious like additive next step to this demo?
Yeah, so I think we basically, so there's a few things. So one, defining DNS, but that seems like it's not going to be that complicated because I imagine that we just want DNS to look like it does today for in-cluster services. I think that the bigger thing is we want to actually define some things around, and this is what I really want to talk about today. But I really want to define some some characteristics about how those cross-cluster services are merged, because I think that kind of dictates how we go about what we do next. But I think the real next step would be to try making a solid kubeproxy based implementation, so this can actually work, and then figure out the testing strategy for how we, basically what would it take for us to consider this implementable. But here, let me switch to a deck. So
Is there a GitHub repo where I can get my hands on this and try to run it myself?
Yes, I will throw it up on the meeting notes. And
okay,
again, before you do that, my kubeproxy patch is awful and hacky, so just beware.
Okay.
Out of curiosity, how is kubeproxy getting that data now, and how are you handling the routing?
So basically, kubeproxy turns all of its services and endpoints into internal base service port structs, and endpoints into its internal struct. So basically, what I've done is I've actually added the service import as a first-class API construct, and kubeproxy watches it just like services, and then also knows how to associate the multicluster-k8s.io service name label with the imported service instead of the way that it does the traditional service name label with standard in-cluster services. So basically what happens is all this gets read into kubeproxy and then just converted to standard internal structs. So the actual routing is like kubeproxy doesn't differentiate in IP tables between multi-cluster and in-cluster services. Now this works because, go ahead.
No, that's okay. Go ahead.
This works because the first thing that I did was basically add routes between all of the nodes in my two client clusters so they can actually talk to each other and flatten the network.
For the changes that you made to kubeproxy, did you implement service import as a CRD, or did you have a build of Kube where you added it to the Kube API? What did you do there?
Yeah, I had a build of Kube where I added it to the Kube API. So that's a question, is how we go about that. Part of the reasoning is the same reason I think endpoint slice went with that route as well. It does perform better than CRDs, and kubeproxy, basically to watch things, the CRDs need to be created before kubeproxy starts, and it's one of those components where that can be tricky. So I've been thinking about other models to go about this. Like to me, it seems like this should be a CRD, but in order for that to work with kubeproxy, it kind of seems like we're going to need some kind of live plugin model, so that we can start a sidecar or something after kubeproxy starts.
Yeah. I think probably interaction with kubeproxy deserves a lot of thought and communication with SIG network.
Absolutely.
I don't want it to mean that if you do something that touches the proxy that it has to go into the Kube API.
Yeah.
And certainly the API type suggests a CRD. It doesn't need to be anything but a CRD. I have no idea what degree of pluggability there is within kubeproxy, or that may be planned.
Yeah. So I've been looking at that, and currently I don't believe there's any really, but there's all the right things to add it. There's a layer within kubeproxy where if you can create a service port and set of endpoint structs, it will just do its thing across all of the different implementations. So I guess the question is today it looks like you kind of need to plumb things through as as protos if you want to pick them up with kubeproxy, but we could fix that, and then this could be a CRD, because this would be great if it wasn't compiled in.
I am under the impression that you can still serve protobuf with CRDs. Is that not accurate?
I don't believe so.
I
Okay.
believe that is
Um,
false for the moment.
Well, that's too bad. I am hearing us describe basically a distinct KEP that is kube proxy pluggability if we think it is worth it.
That's kind of what I was thinking. I guess, Tim, since you're here, what are your thoughts on that?
I have no objections to making kube proxy friendlier to these sorts of extensions, as long as they're not, ridiculously horribly invasive on kube proxy. I have to wear both hats here. So
Right.
in general, kube proxy could do with some cleanup work anyway. In fact, I was thinking about spending part of an intern on some of that. So if the objective is to make some particular extension point available, even if that's a patchable extension point versus a runtime extendable, we can talk about what that would look like. I'm happy to have that conversation.
Awesome. Yeah, and to its credit, I've got to say, actually hacking this in was not that difficult. So that gives me hope that that whatever we propose here to make it more extensible is not going to be that painful. With a grain of salt. But yeah, this actually making this work was not too difficult at all.
Is there any reason that you can't just run a separate instance of kubeproxy and manage the tables with a different label?
I think probably the biggest one is performance. No, that would technically work for sure, but you basically need to watch all endpoint slices from both, which kind of change frequently because it's client-side filtering on the labels.
So you don't actually have to, though. I mean, for the imported ones you do, but for the exported ones, they're reliably named, and there's a hash function that they use for what the service name is, and you can program the rule to point to the existing service that you have for the local cluster, but only do the imported rule that you would program.
For the endpoint slices? Because
Right.
there's...
So the endpoint slices end up getting programmed into a separate chain, and that chain could be reused. I've done this previously where the chain naming is reliable, so that if you wanted to program like your supercluster rule, you would program a chain for the imported set of endpoints.
Oh, yeah.
But the local endpoints, you wouldn't need to watch for those. You only need to watch for the imported ones. Sorry,
not on the IP table side. On the Kubernetes side, you'd need to watch all the slices. And so there would be a lot of processing there. Basically, I think we'd probably end up using twice as much memory for both kube proxies. But then on the IP table side, yeah, I think implementation wise, it would work. The biggest issue is probably contention. If we've got two processes trying to update IP tables at the same time.
Actually, the biggest problem might be surprising, but it's probably going to be memory. IP tables has to load the entire rule set, parse it into native structures, insert what it's going to insert, then force it back down into the kernel. So for a very large rule set, that can be tens or scores of megabytes of memory, which you have to provision for in your daemon sets, which become really obnoxious. Or you your system. Ask me how I know.
Right, but what I'm suggesting wouldn't be duplicating any chains. You would be using the chains that are programmed by kubeproxy, and then adding supplemental chains for the imported services. So you wouldn't have any anything that wasn't there would be no duplicated rules, I guess is my point. And as far as watching the endpoint slices, you're taking the imported endpoint slices and creating those in the cluster that you're doing the import into?
Right, that's right.
So if you were to provide a label for those, that you labeled them as being imported, then you could limit what the watch would be to only the imported labels.
Yes, but so it wouldn't trigger updates on every endpoint change, but it does mean like we're going to create a cache of all the endpoints, right? Because the label filtering is client side.
Label filtering, no, if you create the watch with a label, it's filtered on the server.
Oh. Cool. All right. So maybe that's not so bad. I thought it was client side.
I mean, just an idea. Like, I think that you'd be able to have a separate process, so you're not stuck with whatever the timeline is for kubeproxy to implement this stuff. I think that you could actually do a second daemon set, limit it to watching your endpoint slices for what's been imported, and then reusing the chain that they have for the in-cluster service.
Yeah. I mean, I think like regardless, that seems like a pretty good place to start. Like just so we don't have to wait, because I don't see any reason why that wouldn't work. The only concerns, I think, as Tim pointed out, are scalability. What's the impact when it starts getting very large? But maybe that's not such a big deal. I think we should probably try it out.
Yeah, I mean, we've talked about this a little bit. I'm super down on having multiple things trying to coordinate with IP tables, just because I front all of the IP tables bugs. But it's for lower scale, it's probably much less of an issue than for higher scale, right? And so I may be over biasing my thinking for some users based on the experiences of others.
Do you think that it might be a workable approach that would eliminate blocking on like a KEP to enhance the proxy pluggability for small scale?
Sure. I think for getting people unblocked, I think it's completely reasonable to just try and go do your own thing. I don't know if like I would want to ship that as a product to try to support that, but for people who want to work on it, yeah, it seems reasonable.
Yeah, I think it might be easier to justify a need for the proxy KEP if we had something out of band and we could point to, at X scale, it gets silly to do this in this way.
Yeah, no, I think that absolutely makes sense. Yeah.
Is there any concrete data on this?
No. I mean, nothing for what happens when we've got two processes running IP tables at the same time. There is work being done on endpoint slice scalability right now.
We had some anecdata from the IP mask agent experience where it was writing a very small number of IP tables rules, but the number of rules you're writing doesn't really matter. The number of rules you're reading does. And it was at the order of thousands of rules. It started to consume, it felt like nonlinear memory, but it was anecdata, not rigorously gathered. Basically, we caused a bunch of systems to by doing something that we thought was obviously safe.
Okay, so basically, we need a good test case for this. Is what I'm hearing. Probably either way. I guess one benefit to the to build it. I mean, the obvious benefit to building into kubeproxy is that presumably we'd scale as high as endpoint slices do for in-cluster services across multi-cluster without adding a new bottleneck. But I absolutely agree with Paul's point that we'll have an easier time building or proposing an extension mechanism if we have a real use case to point to. So unless there's anything anyone wants to bring up more on that, I think there were a couple.
Just a quick note. I found the issue in KK about binary encodings for CRDs It cites Proto as an example, but David is telling me that there's like not a clear consensus on Proto versus something else. So I dropped the link into the chat if anybody wants to go look.
Oh, awesome. Cool. So here, let me share a few things. So I guess going back to kind of the actual implementation, we kind of touched on a few things last time about having services in each cluster export and being kind of merged into the supercluster service. But I think there's some open questions about the actual mechanics of how that works and how that should work, and what happens if two exported services disagree. So let me share. All right, so when merging these services across clusters, I think the main goals that I want to highlight here are retaining all of the existing service capabilities that actually matter, that people would expect to use in a multi-cluster environment. Having some intuitive conflict resolution. I'm just going to say up front, I don't think it's going to be possible to automatically merge any two services with disagreeing spec, but it should be very easy to understand why anything failed. We try our best to remain functional. So that said, we try to do the automatic right thing in an intuitive way whenever we can. And then we want to be able to support incremental rollout. There's not going to be any nice way, even if we have a good orchestration over this, there's not going to be any nice way to do atomic updates across multiple clusters. So you should be able to change characteristics of a service in cluster A without breaking an export from cluster B, if only temporarily while you update everything, do a rolling update to a new version. Does that kind of make sense to everyone?
How are the failure states handled?
Good question. So I think that's something we should talk about. But first, I want to talk about what could cause it, or actually maybe we can dig into that now. So so I guess, yeah, let's talk about the things that we probably don't care about first, so we can kind of agree, because I think the answer will depend on what caused the failure. So I don't think any of these immediately matter. Like these will be kind of ignored properties on a service that's exported. I don't think they necessarily impact this aggregated service at all. So cluster IP, any of the external IPs, external name, external traffic, health check, load balancer, any of the load balancer config, and selector are definitely local to that service. We only care about the endpoints of a cluster IP service, so those don't really play in. And then publish not ready addresses, we probably do want to figure out, but not until we figure out how we're going to support headless, multi-cluster headless services. So it doesn't make sense for a supercluster IP type. Any disagreement there? Cool. So
these are fully ignored, right? And
yes.
Okay.
So yeah, every cluster could have its own value for this, and we won't for any of these, and we wouldn't. It wouldn't impact anything.
So just maybe a quick question. For the health check, are you actually performing a health check on the imported source? How do you determine when one of the remote endpoints provided by the endpoint slice has become unhealthy and no longer route traffic to it from consumers?
Good point. Good question. So I think, first of all, the endpoint will be exported in its current state, right? So if it's ready, it will be exported as ready. If it's not ready, it will be exported as not ready. That said, I think one of the things in the KEP that maybe needs to be louder is that the endpoints that are imported into a cluster are a representative set of endpoints from each cluster, and these endpoints are expected to be fungible, and the controller can do its own optimizations for some cost metric or whatever. So I think the default would be that the endpoint, if it exists in the exporting cluster, whatever state it's in, it is imported in the same state. But a controller could do whatever it wanted to perform additional filtering or health checking. And I think I'd rather not define exactly how that needs to be done. I think that would be up to the implementation.
Okay. Thank you.
Absolutely.
So just going back one slide, like I think a variable that we said was fixed was also that we're only caring about cluster IP services right now, right?
Right. Or, I mean, you could, yeah, cluster IP or anything that ends up with a cluster IP. So like a load balancer node port service would be treated as a cluster IP.
Okay.
I think the big thing is external name doesn't make sense, right? Like I don't know what that would look like when merged with another service in a supercluster. But yeah, we just care about the cluster IP part of a service and its endpoints. So I think then let's talk about the properties we really do care about, and just kind of a reminder that this is the import. I haven't updated the name. There was some feedback that service import is a better name, and so I changed that in the KEP, but haven't updated the graphic. There would be basically a cluster spec for each cluster with some implementation specific unique identifier. So whatever you're using as your cluster registry would use this identifier, and this would be the same identifier that we use as the source cluster label on the endpoint slice. And so the things that we do care about are the IP family, of course. We can't really merge across IP families. Ports, service ports, session affinity, and topology keys. So I think it would be probably helpful to talk about how, I threw down some ideas of how these should work, but I think we should just talk through what these actually could look like. So IP family seems fairly straightforward to me. Like you can't merge an IPv4 and IPv6 service because IP tables can't route between the two.
So note that IP family is not an explicit field yet, right? So you have to figure that out by tasting the addresses, or in endpoint slice looking at the address type, right?
Is it not an
But the
explicit
service
field yet?
itself, it's a part of the dual stack proposal, which is still alpha and undergoing some aggressive rethinking right now. So there will eventually be a way to know for a given service if it has a restriction on IP families, but it's not guaranteed that actually the IP family will even be set on all services.
Okay.
It might be this service does both. We're arguing that out.
Okay. So I think we probably want to follow suit then. Like, I'm assuming if a service does both, then IPv6 will route to IPv6 and IPv4 will route to IPv4. That seems like we could do whatever service is doing there.
Yeah, I actually, Jeremy, I should point you at a doc where you can maybe spend some time thinking about how multi-cluster and dual stack should play together. The question on the table is, if you just heard dual stack is now supported, what would you expect to happen?
Right. Yeah, okay. Yeah, please do. So I think, in short, I would revise this to IP family, we do what service does. So if service is either or, then we'll be either or. If service ends up supporting mixed, we'll support mixed however service does. Does that make sense? Cool. So service ports. So the thinking there was you may want to change service ports. So we could just export the union of ports from all exporting clusters. So that would be what's imported. The problem there is if two clusters declare a service port with the same name but different ports, I'm not sure how I would reconcile that. So I think the right thing to do would probably be to fail, but this would be one of those hard failures where we wouldn't know what to do. So we'd have to report an error on the export, and then we need to decide how that's handled. I think the safest thing is to probably stop performing any action, so no updates. I don't think we should delete a service because it was, or I don't necessarily think we should delete a service because we no longer know what the right thing to do is, but at the same time, we should assume that those endpoints will become stale very quickly.
So I think this would be like a really profitable thing to explore as the next step on the KEP. How would you ripple that information back to the service export? And you know, what would you expect as a user to happen?
Right. So yeah, I mean, the initial thinking is that all service exports involved in this conflict would get a condition set. Basically, that there's a with some kind of description of what's conflicting, and I think maybe a roll up of the conflicting property across clusters. I don't know. You know, we don't know which one's the problem cluster because there's no priority.
Yeah, it's definitely worth thinking about what kind of trouble you could get yourself in by rolling up the property across all clusters, right? Like you could, it's easy to imagine a scenario where you could run out of space in etcd to actually put that information in there at some amount of scale. It's certainly a fine start, you know, for low scale, but definitely deserves some thought you know, as this would transition to more mature API levels.
Yeah, that I agree. So that's worth writing out for sure. Does anyone have any thoughts they want to throw out on how this could work? Cool. I'll take a stab at kind of writing up in more detail how this would actually be expressed back in the KEP.
Yeah, I think what I'd probably suggest is PR your PR, or make a PR that depends on your initial PR, so that we can merge what has settled so far.
Okay, cool. I will do that. Yeah, so I'll stop updating the initial PR today and start a new one.
Cool.
And then session affinity, that one's kind of tricky. So there's no reason like we couldn't plumb that through. It's something that actually is expressed on a per endpoint basis when it's actually programmed in IP tables. And I'm pretty sure it's handled similarly in IPVS. But that one's tricky because, well, we could have different session affinities for different endpoints. There's like the flypaper effect. If you have one set of sticky endpoints, eventually they will get all the traffic because everything's randomly routed until it finds the sticky endpoint. But this seems like the safest way to support incremental rollout of a session affinity change. Any thoughts there? I think one thing that I'd want to specify is that this should only be like, and this is probably more of a documentation thing, but this should only be used temporarily in, you know, for relatively quick rollouts. Obviously, you wouldn't want long-term differences in session affinity.
Yeah, this seems like it seems like you've thought thought about it a lot. I think it's going to be really important to explain whatever semantics we land on. So definitely a tricky thing that will take a lot of effort in the cap.
Yeah.
Yep. Jeremy, we've talked about this at length. We never really came up with what we thought was a great answer. The thing that still nags at my mind is, with endpoint slice not being GA yet, we've talked about making changes to endpoint slice to try to minimize its footprint so that it integrates better with, managed services and things like that. We just need to figure out how all those things intersect.
Mm-hmm. Yeah, maybe this is something that could be moved up into endpoint slice or down into endpoint slice, however you want to look at it. So, we're just doing whatever endpoint slice thinks it needs to do. But yeah, that's probably a conversation that needs to happen with SIG network as well. As with the next one, topology keys. So service topologies kind of in a little bit of flux right now, I understand. Tim?
Flux would be a gentle way of saying it. Yeah, I mean, the topology keys is another alpha feature that, as we explored it in alpha, the general feeling right now is actually maybe we shouldn't do that, or at least not this way. This is something that we have some very rudimentary research into doing more automagically. So yeah, you can, for this point, I think you can choose to either support the alpha API or just ignore it and tell people don't run super clusters that span high latency edges of the graph, because we're not smart about that yet.
Yeah, I guess maybe a better way to put this would be that whatever we end up with topology, it seems like an endpoint should respect the same topology rules, no matter where it is. So whatever rules apply to it in an exporting cluster, that's where the service owner is configuring it. It should probably be imported with the same rules. So if an endpoint is created with a service that restricts traffic to the same zone, when it's imported, it should probably also be restricted to the same zone, whatever the semantics are that we end up with for how that's expressed. Does that make sense to everyone? Any conflicts there?
I think it makes sense. I am going to have to keep thinking about this as someone who is not an expert in this area. We are only scheduled to go through 15 after, so it might be good to move along if you've got a couple more slides.
Yeah, well, I think probably the next one, so it's a good time to wrap up here. So we kind of talked on CRD versus Proto. CRD would probably be better if we can make it work, but we need an extension mechanism for kube-proxy, or at least to build our own external kube-proxy. But I guess what's missing, and we kind of touched on what would be criteria for acceptance. I think those are the big pieces. Like what do we need before we can move from provisional to implementable?
Yeah, I'm starting to think that might be a longer road than I initially thought. I think in order for that to happen, we have to have what we think is a tractable way that we could efficiently implement this, that would lead us to a path where we could eventually call it GA, right? Like, yeah, or V1 supported. I feel like the problem in front of us is how do we prototype it? So it suggests like a journey between the next step and the end of that story.
Yeah.
For my own gut, I feel like a way to prototype it to demonstrate the core value and like have something that works at low scale is probably really important to getting
Mhm.
enough like critical mass in the community to get us to a point where we can have buy-in from the stakeholders that would be required to do things like have a plugin model for the kube proxy. So that's probably the next step.
Yeah, I agree. And it seems like a like second kube proxy for multi-cluster is an okay way to start there, and it will surface a lot of the problems. And then we can start with the CRD too, which is really where we want to end up.
I would suggest that Jeremy, if you want to move the ball forward on that, you could probably start with a repo under your own GitHub account, and once we have something real there, we can talk about moving it into Kubernetes SIGs potentially.
Okay. Cool. Yeah, I can do that. And then the other thing I was thinking about is, we just touched on it, but topology. Knowing that there is some plan, I think will be very important in multi-cluster, because I'm sure people will want to be able to span, high latency network boundaries.
I think it's fair to say that there will be a plan. The question is exactly how automatic it will be versus how manual, and where that data will be carried is the interesting bits. Basically the conversation comes down to, is it a controller that's going to consume the bits and tell you just use these ones, trust me, or is it going to be like we're doing here, pushing all the information down to each of the clients and letting the clients make a decision?
Yeah. That to me seems like it's a very important piece, and it needs to be in for this to be viable. But I don't see a high likelihood of the in-cluster topology scenario working itself out in a way that doesn't also fit multi-cluster. So I'm less worried about how that ends up coming to be. It's just more that it needs to come to be, if that makes sense.
Yeah, makes sense. I think we should probably call it here since we're running over. But this is a great discussion and great presentation, Jeremy. Thanks a lot.
Absolutely, thank you.
All right, thanks a lot for coming, everybody. There is not yet an agenda for next week. Feel free to write something into the agenda, and we will cancel it if nothing winds up getting written in there. But thanks for coming. Have a great day.
Thank you.